We start with property of Laplace transform of Laplace transform. First property, linearity. As discussed in Fourier transform, linearity is combination of superposition and scaling, homogeneity. A2x2t transform of this is a1x plus a2x2s. ROC is common area between R1 and R2. Now move on to next property. We are not strictly told about ROC because ROC is always confirmed from last expression. We are not sure about ROC because due to maybe pole zero cancellation at last expression. For example, I took an example x1 plus x2t. Laplace transform is combination of two component. First component is have Laplace transform, second component have second Laplace transform. If I consider first Laplace transform is 1 upon s plus 1 minus 1 upon s plus 1 s plus 2. If I solve this expression, s plus 2 s plus 1 multiply with s plus 1, there s plus 1 is cancelled with denominator, numerator and denominator s plus 1 is cancelled. Now ROC is revised. As per first expression, ROC is greater than minus 1. As per second expression, ROC is greater than minus 1. Combined result is ROC is greater than minus 2, means extension of the ROC due to pole zero cancellation at minus 1 location. So ROC always calculate from last expression xs. Always calculate from last expression. Move to second property, time shifting. Time shifting property, if Laplace transform of xt is this time shifting property, delay in the signal produce some additional component in s domain. Third property is shifting in s domain. We can prove this property through change of variable property, change of variable idea, because our basic formula is xt e power minus st dt. Instead of putting xt, if we put here this component, then we got result in this way. The property is just change of variable, shifting in s domain. If a exponential term multiply with this, result is change in s domain. ROC also modified. If we use negative component here, result is thus. We add these two components, result is Also revise. If xt is replaced with ut and we add these two components, x s minus s0. If xt is ut, then cos t ut is s minus omega naught s plus omega naught. We can write direct omega naught expression for cos omega naught t ut is s square plus omega naught square s. For sine, we can direct write expression in this way: omega naught upon omega square square. ROC for both is defined from ut. We can write one more expression which is come from this expression just by replacing s is replaced with s plus a, and we get another Laplace transform with the help of this idea. Second term we get from e power sine omega naught t ut omega naught s plus a square plus omega naught. Next property, time scaling. If xt is xs, time scale signal may be compress or expand depend on value of a. It is compression, it might be expansion. Compression. With this scaling we get modification in Fourier Laplace transform is in this amount. Specific case time inversion. If a equals to -1, time inversion. Specific case a equals to -1 minus s. It is a specific case of scaling. If signal is time inverse, S domain transform is also time inverse. We took some example before moving ahead. Simple Laplace transform example. Del t. Laplace transform of del t is 1. It's come from formula. Basic formula is known to us is by putting location value in this we get result is 1. If some modification in this expression, shifted impulse, we can calculate from result is e power minus S not for all S, entire S plane. ROC is entire S plane from 1. 1 is valid for all S region. Next example, third one, ut minus ut minus 2. We want to calculate Laplace of it. Ut, Laplace of ut is ut e power. For ut Laplace calculation, ut defines the range of integration. By solving integration, we get this result. Greater than 0. So I directly write down answer here. And final answer for this Laplace term is, and ROC is 0. Question number 4 is somewhat different question I took. Summation del t minus kt, some different type of question I took. Now first, this type of question also cover in maths also. Now I took different type of example. A discrete sequence, a periodic sequence discrete from 0 to infinite. If someone draw this at 0 location, at t location, at 1 location, 2t location, 3t location, and so on, value of this is 1. Impulse train start from 0. I want to calculate Laplace of it. 1, put 0 del t plus putting value 1 t minus capital T del t minus 2t and so on. Laplace of this. Laplace of impulse is 1. Shifted impulse is e power minus st. Again 2 amount shifted impulses, 3 amount shifted impulses, 4 amount shifted impulses. It will construct a GP. Solution of this GP is a GP start from 0 to infinite e power minus st. Total term is infinite. Infinite GP. Solution of infinite GP is first term a upon 1 minus r. If GP is a plus ar square plus ar cube and so on, r is always less than 1. GP solution. First term I have 1 and r is e power minus st. This is the Laplace for this term. Summation lt. Laplace for this term k equals to 0 to infinite e power del t minus kt. Laplace for this term. This term is responsible for periodicity. If any signal repeat after some time, some period is there, we can directly multiply. First we calculate the Laplace of particular aperiodic pattern and then multiply with this, because reason is that a triangular pulse multiply with impulse train started at 0 location, result is repetition of this triangular pulse after this period. 3t, 4t, 5t, 6t, 7t. So first calculate Laplace of this and then multiply with this pattern. It means it pattern will repeat. The basic idea to calculate periodic signal Laplace transform is first calculate the Laplace transform of this, and to make periodic multiply with this term. So net formula for periodic signal Laplace transform is x 1s 1 minus e power minus st. T is period of repetition. Xs is basic signal. Basic signal in a period. In a complete period, a basic signal. It may be rectangular pulse. For all type of periodic pattern, we can calculate Laplace transform for them. This type of periodic pattern I am using here. Minus t by 2 to t by 4 to t by 4, t by 2, 3t by 4 and t is repeat after this time. Total fundamental period is t. So first I calculate Laplace for this pattern. After that, this pattern Laplace for this pattern is function definition. x1t is 1 for t minus t by 4 to t by 4, otherwise 0 for a period. First calculate Laplace for this and then repeat it for time period t. The Laplace of this is, we use this Laplace transform for a period and make it periodic through this idea previously discussed. E power st by 4. This Laplace transform come from formula basically. I put the within the limit, I put the value, solve this expression, I got this. We can convert in hyperbola pattern or directly use it. As 1 minus e power minus st. T is period of repetition. If I can take common from this, e power st by 4 upon s 1 minus st by 2 1 by t. We cancel out one term. This term can be segregated in two parts and we cancel out one term. We segregate this term in two parts and final result come to us is 4 upon s 1 minus 1 plus. We can get a periodic pattern Laplace transform with this idea.